Hey, Chem 2P21 students, Ian Gordon here, science librarian from the James A. Gibson Library. Give you some tips and tricks to help you feel more comfortable to complete this really neat assignment in a timely manner as well. I'll go through a series of slides and I'll show you where they are and other things that may be important to you as you move through this particular session. First of all, the objective of this exercise is to explore the biomedical, chemistry, green, and patent literature, so we'll take you to different areas. This exercise involves searching the chemistry literature in different ways, looking for information, using articles like Reaxys and SciFinder and Web of Science, looking for patents, and using different tools that you may want to use to be successful. First of all, we're going to start at the Brock Library homepage. A number of things, including Omni, which you've probably used to find books, streaming video, and articles as well. Our hours, we're not back yet, but we hopefully will be in the new year. But if you look at the research guides in the bottom corner, that's where we'll take you to a list of library guides for different faculties and different subjects. The chemistry guide is the one that you should be looking at. And on it has a number of things. On the left-hand side, it allows you to look for books and articles, properties. Interlibrary loan is introduced there to get materials from other libraries for free. Writing and citing careers. It's a neat books that are talking about careers in chemistry, help, and Chem 2P21. There's a tab specifically for that. If you look on the front page, it introduces you to who I am, Chemdraw, other sorts of databases, ACS Guide to Scholarly Communication we'll talk about, new databases that are kind of neat. And the bottom, there's a listing of electronic books to help with synthetic organic chemistry and textbooks as well. If you look on the right-hand side, it says your librarian, that's me. You can email me at any time using the form there, or you can book a consultation. So if you clicked on that tab, it would bring up a date or dates and times where I'm available. You can click on it. It asks you why you would like to meet. Then it schedules a meeting with me and with you, and then we get back and using Teams or Zooms. We'd have a meeting if indeed you need help getting started, something doesn't make sense, or you just like to meet with me at any particular time. The Chem 2P1 guide is there, and here it is. It's a page I've put together for this particular course. It gives you a sample article, the ACS with title Citation Style Format. There's a patent that's listed there. The ACS Guide to Scholarly Communication, a link, and I'll tell you about that in a minute. And where the arrow is, there's the blank form for this exercise, which will probably be on Sakai as well. And then there's a filled out form. So I actually did this assignment and used amoxicillin. That's a drug that you can't choose. Just to give you a sample of what the answers and what the questions and how it may work. And I actually did it for you as well. Below it are the slides I've used for this presentation. On the overview YouTube you're watching now. And there's some more YouTube videos on SciFinder and Reaxys. If you've never used them before, just to give you a heads up on how they work. Sometimes it's new to you, but it can be confusing, but I'd like to help you so you can be successful using these databases at any time. As you move further, there's the Chemdraw Web Registration. If you choose to use that software, it's actually the industry standard. So if you're a chemistry major or Chemdraw wanting to know, that's where you'd sign up and you could download that for your own workstation or PC. SciFinder, registration forms, because you have to get a password to use it if you don't have one already. CASI, which is the abbreviation guide for journals. And the documents that you'll need, including two INA biodocs that I found particularly useful. But let's carry on. Here's the exercise and all the blank forms. So you download this and fill it in. It'll take you about an hour to move through it. You can start and stop it, but you need to complete this in the example that I showed you and fill in where there's a blank for a number or fill in for a point where its commentary is needed as well. Here's that one I used for amoxicillin, and it's used to find a number of things. As you can see, I filled in all the questions, put in commentaries, 1 or 2 sentences at the most. It took me 2.5 pages to fill in, and this is what you would hand in. First of all, you click on Home in our library. There's the articles databases, and there's lots of article databases. Some are chemistry related. Some are interdisciplinary, and some you've used before, like Omni, which is at the first, and Google Scholar, which is a good blunt instrument. But it doesn't think like a chemist. It doesn't search like a chemist. You can't search by structure. You can't search by substance. You can't search by reactions. And so you have to speak the language of the database. And that's why we want to introduce you to SciFinder and Reaxys today. SciFinder is here and it gives you a link to it, but you have to register for it. There aren't too many databases that Brock you have to register and sign in, so you need an alternate username and password. And if you've forgotten yours, you can get that loaded as well so that you can be set. SciFinder usually works on all workstations, mobile devices, and laptops, but sometimes there's settings that don't work well, so get back to me if there's a problem as well. And there's some videos at the bottom that you may want to look at. They're short videos that gives you basic examples of how to search by general, structure, and reaction searching. Reaxys is another database in this list of about 30 databases that you may or may not want to use. It's different, where SciFinder is a American Chemical Society tool. It's kind of North American in thinking. It includes dissertations, it includes patents, it includes core journal articles and other sorts of materials, but it's quick to get things up there. There's thousands of articles posted every day. Reaxys is a bit different. It's an old world tool. It's a European basis. What they did was they added the literature and evaluated it. So they only added literature that they thought was important, and it would add to the body of knowledge. Embellishing is what it used to be called, but now it's called Reaxys since it was bought by Elsevier not too long ago. It is famous for its physical properties. It's an interrelational database. It's for its coverage of articles and alternate coverage of tools that you can't get any other way. So both these tools work well. Some work better than others. Some chemists, particularly your professor and others in the department, use both because it gives the same but sometimes different answers for the same sorts of questions as well. There's a video you can look at. And Web of Science Core Collection. It's a database of core journals in all areas of science. I'll show you how I would use, because one of your questions, you need to find a particular article. There you go, SciFinder and Reaxys. On this tab, you find chemicals and drugs, and there's lots of them to be had here. Now, it'd be nice if we had one place to go, but there's many biomedical, open, proprietary, company or corporate, different types of dictionary databases, interrelations. Some are just so amazing that I list them there because I use them all the time when I'm answering questions for students and faculty. ChemBook, ChemSpider, dictionaries, Drug Bank. Drugs.com is excellent because it only gives commentaries. So when you answer questions about how your drug works or pricing, some of these are catalogs, some of these, some work better than others, but explore them all until you get your answer. Medline, the National Institute of Health in the United States, is a huge proponent. Like PubChem is an amazing tool. You just need to go there. So in addition to Reaxys and SciFinder for finding drugs and chemical information, there's other tools that you can use here as well. Patents. Patents is our great type of literature. They're things that are novel, new ideas, usually by corporations, but sometimes academic institutions, present as to want to be first to the post and copyright or trademark or just be the first to subscribe to an idea before somebody else does. It's a huge area of literature in corporate chemistry and biomedical and biochemical research, but it's also important for researchers to know that you aren't doing something somebody else has already done, and it's not commercially applied in a patent such that you wouldn't want to infringe upon that. So you do a scholarly search and a patent search. So patents aren't like articles, and they aren't like books. They aren't like theses or dissertations. So they're a whole new format of literature, but really important to chemistry. Here's the Writing and Citing tab. It's a really important one as well. On the top, it tells you tools that you can use to do quick citations for articles, and that usually works quite well. There's the Purdue Online Writing or OWL guidelines for common formats, but not for American Chemical Society formats. For style of what number goes where, do you type in 9 or use the number 9 when you're writing up something? How do you do tables and graphs? So the American Chemical Society, which is the standard for writing up materials, has their own ways of doing things, kind of like APA, MLA, and Turabian do as well. There's a number of tools here on this particular page. Guides in the bottom that I use. I don't create my own when other people have done such a great tool. So Murdoch and Williams and UMadison, Wisconsin have excellent guides that give you good answers. Or you can just Google ACS style with title, journal article, and give you an example. You can crib from there as well. On this page, there's two things. One is Zotero Bib. It is amazing. I want to show you how that works. It's a free online search that links to Zotero, which is a citation management system. You may have seen me prescribe before for you. But if you look at it, it's just a free service. And you can put in a number like an ISBN for a book or You type in the title of an article, and sometimes it'll find it, sometimes it won't. But if you type in the digital object identifier number, which is unique to most journal articles, and pull up the American Chemical Society style, in addition to hundreds that are there, it creates your own bibliography citation style, as you see on the bottom of the screen. And you know what? It's pretty accurate. Two things it does. One, it gives you the format and the italicized that you can cut and paste. Some things you may have to change. It includes the DOI, which is sometimes you have to go search and find. It highlights things like it does for that particular style, but it also gives you the abbreviated name of the journal. See what it says Chemdraw. That's just an American Chemical Society style thing. So it does that for you for most instances. It doesn't include all journals for all things, but I use this not only for ACS style, but all other styles as well. So Zotero Bib, I think it's the best citation tool. Quick and dirty and the most accurate. And another thing it does is not only is it accurate, but it keeps up to date with the rules as they're changed over time as well. So try Zotero Bib. The other tool I want to show you too is the ACS Guide to Scholarly Communication. I know you have other tools in Sakai you could use, but this is the current subscribe to guide that we use. And let me show you when you click on the link. It's a document that it's digital, and it's upgraded all the time, as opposed to a style format that's changed with version 1.2 and 2.4. It's updated all the time. Since we subscribe to this, there's many chapters on how to write, how to edit, how to do research, and on part 4 is scientific style communications. It references, and so on the bottom I give you an example, and it gives you an example of how to do an article, and has examples of how to do everything from web pages to TV videos to patents to journal articles to books to chapters of books. So it's the de facto standard for American Chemical Society style decisions, not only on writing and formatting your paper as you move forward, but also for references as well. So consult that if you need to. It's a great resource. Back to writing and citing, I told you a couple of things. Zotero, as I've looked at the top there, is fast becoming one of the most applicable and most important Zotero. So if you're moving on in chemistry, biomedical sciences, you need to decide on a citation management system that works for you. And increasingly, Zotero is the tool that you used. Book an hour with me for consultation. I'll demonstrate it. I'll show you. We'll help you load it for free on your workstation. Once you used it, most people go, this is amazing, because not only it tracks and adds my notes, but it links to all the PDFs for the articles that I've downloaded. So try Zotero. If you move farther down this page, there's help with writing guides. So they have a chemistry focus. So in every one of my guides, I produce digital tools like Write Like a Chemist, how to do proper lab report writing. So if you're ever wondering, we want to be better, we can always be better at writing and doing things. Consult these as well. They're there for your benefit. So here's the questions we need to move through. Question 9 is an interesting question. There's 8 questions before this, but it asks you, you're hired by an international pharmaceutical research company, and you asked you to respond to this particular document. It's a CDC, Center for Disease and Control's antibiotic resistant threats in the United States. You're kind of looking at this on this particular assignment, and it asks you to use your favorite scholarly database, find a recent scholarly peer-reviewed experimental, biochemistry, biological, a pharmacological, chemistry journal article. So it has to have that emphasis, and I'll tell you why. Using one of these 18 antibiotic-resistant bacteria fungi listed in this particular report, and speak to this threat. So you need 1 or 2 sentences for that. This article has to include an experimental methodology, so it can't be a review. It can't be a commentary. It can't be a social sciences or a survey, which is happening in medicine, like how much resistance is out there. It has to have data, and it has to have experimental methodologies. And you need to use this paper because you're going to talk about it in the next question. I'll go over that in a minute. So you go to the document, you read it. This is just the table of contents, and there's those serious threats, urgent threats, and concerning threats and a watch list. So pick one of those particular chemical or biological agents that you need to look at. And I go to Web of Science. The reason why I use Web of Science is that you can use Google Scholar, Omni, Microsoft Academic, or any other tool that you think follow, or you can use SciFinder or Reaxis. But the neat thing about Web of Science is it's only core journals, and it covers journals that cover a spectrum of things. And here's the search I did. I picked Shigella, I think that's how it's called, as one of the challenges or threats. I looked for it, and I found too many articles, so I went back. You can go back and forth. I said I only need 1 article, so let's look for the word in the title. Then I put in my other terms of resistance or antibiotic, and when you put that *8 at the end of that word, it picks up any word with that root, like antibiotics, or resistance, or resisting. Then I found too many, and topic in Web of Science's words in titles, words in abstracts, words in article citations, and keywords and manufactured keywords as well. I still had too many. I only have to find one, but it has to have experimental methodology. So I put in terms like biochemistry or chemistry, chemical, or pharmacology, any one of those roots in the topic section, and I got a result of 121 articles. Knowing they're all articles, I used 3 review methods. On the top right, I clicked on an article as opposed to review or proceeding, so that refined it. I picked on languages and English. You pick anything you want, but we tend to only have English. There's very few that weren't not in English. On the bottom, I picked subject categories. I picked up chemistry, biochem, biotech. You can use any strategy you want. Improve your search strategy, browse. And at the top, see where it says you can sort these records by date, meaning newest to oldest. Time cited by more cited than less cited over time. Usage, meaning how many times these records have been looked at by you and other people. And by relevance, kind of like a Google search interface where it looks and finds the most appropriate based on your keywords and searching as well. So 121 articles, and you can go through them all at your own leisure. You just need to find one that has experimental methodology. So I went through them all, and I looked at this one, I looked at that one, and then you can set them to one side. I sorted these by time cited. 464 times this article has been cited over the last number of years. You can also limit by date, but you can use these tools at the top to flip the order to look at different things. I looked at a number of records that were here, and decided which ones were appropriate. So another thing that you can do is look at, hold on while I fix this, is browse. So what I did was when you can highlight these, you can click them and put them in the top right-hand side. It said marked list. So I found 7 in my list of 211 that looked interesting. And then I looked at them and I found this one article. Read the title, where it's from, the abstract, the keywords. But again, it has to have experimental methodology. I actually looked at this. I clicked on Find Up Rock, or it was free and open from a full text record. I included and looked at the article. I looked at the experimental section or the methodology of the procedures to sense that it wasn't a commentary, a survey. It actually had some science dealing with it as well. Interesting, neat is this is the article you're looking for. And see the DOI was there? It's on the left-hand side under the name of the journal. But you can cut and paste the DOI and put it in the Bib Zotero tool and get a citation made for you. So that's a quick and dirty thing to do as well. Stuffed it in and look at the bibliography I got at the airport. So you can create it yourself, cribbing from the examples, but it does it automatically. Sometimes you have to clean it up, but it's pretty good. Question 10, now you've got your article and you cited it. In 1 to 2 sentences, use your own words to comment on whether the paper you've picked, the one you've just selected, for question number 9, is methodology, reactions, data, or techniques. Meaning look at the experimental methodology is indicative of green chemistry. Green chemistry is a growing part of research and practice at scholarly and corporate institutions. It asks you to, how are you following these guidelines to be environmentally green as well? If you click on that entry and you look at it, there's different sections on design principles, and there's a listing of 12 principles to follow. I picked a graphic of these, and so they're talking about how to prevent waste, being less hazardous in the materials you pick, how to do catalysis using easier or environmentally friendly tools. What do you do when you throw this out or you have an accident? So pick one of those. Maybe it's prevent waste or whatever, read about it, and then apply that to the article you've picked. Is that article you've picked indicative of green chemistry? Sometimes it is. They'll tell you that. Increasingly that's so. Many times it's not, so you have to indicate why it's not part of green chemistry. And hopefully as you move forward as a bench chemist, biochemists, medical students, you're sensitive to green chemistry and how we can protect our environment as we move forward and doing the essential chemistry that we need to do. Here's where you need to get help. So on the bottom left, there's a help tab, places that you can look at. Brock A to Z Learning Services. You've probably been involved with that. Chemdraw Razvan is a member in the chemistry department who will help you with that and other things. Copyright. There's a SciFinder 1-800 number and an email. That's really important, not to do a lab or not to do a citation. But let's say you do a search and you go, this is not working, or I'm working with a faculty member, or I'm a member of a research team, and I'd like to know more to be better at this sort of synthesis or reaction or analysis. Email them, give me a question, they usually get back to you within 24 hours. And there are people with PhDs that do this full-time that we subscribe to. So not only do we subscribe to SciFinder, the database, we subscribe to their help desk as well. Reaxys does the same sort of thing, so you may ask both institutions. Really need good answers to difficult questions. And there's other sorts of help areas that you can get as well. So here we go back to the Chem 2P21 information exercise. The slides, the guides, the examples. Check on the amoxicillin guide that I use just to give you a sense of the numbers, and don't cut and paste the answers that I put in because the answers that you'll use are different than mine. But it gives you a heads up to know what's expected and what to hand in. So a good assignment is a completed assignment. Good luck with this particular assignment. Here to help. Email me, book a consultation, or talk to your TA or lab advisor. They're actually great people as well. So all the best, and check out the video for SciFinder, and check out the short video for Reaxys as well. I won't be talking through it, I'll just be showing you how to use it to answer these sorts of questions. So all the best.